Hey guys, let's go ahead and talk about Chapter 3. Chapter 3 covers matter and the different parts of matter. So let's go ahead and get started. Now you already know what matter is, but I need to make sure that you understand that substances are matter and they're types of matter that are uniform and unchanging. Okay, so let's look how matter can be divided, because matter is divided into two major groups. The first group are mixtures. The second group matter is divided into are pure substances. Now, we have two types of mixtures. One is heterogeneous, which means the substance is different throughout. You can see the different parts. The other type of mixture is homogeneous mixture. This means it's the same throughout. So an example of a heterogeneous mixture would be like a salad. I can pick the different parts of the salad out. That's a heterogeneous mixture. An example of a homogeneous mixture would be gasoline. Gasoline is made up of all these different liquids. And so you can't see the different liquids in gasoline. It looks like one substance, and so that's a homogeneous mixture. And then pure substances are divided into two categories. The first is element, which means one type of atom only. It's kind of like when you look at the periodic table. If I'm looking at boron, that's the boron element, and it's only made up of boron atoms. Then we have compounds, and compounds are when you have two or more elements coming together to form a substance. Now, there are four states of matter, and y'all are familiar with these. It's solid, liquid, and gas, and plasma. Now, plasma we will not deal with in our class. We will deal with solids, liquids, and gas, but I want you to know what plasma is, and just that it's lightning bolts and stars, usually things like that, and things related to that nature. Now, solids have definite shapes and definite volume, like your desk, your pencil. A liquid can change shape, but has definite volume. If I have a bottle of water and it has 10 milliliters of water in it, if I turn the bottle sideways, the shape of that liquid changes, but I still have 10 milliliters. And then a gas changes shape and volume. Gas can change both of those things at any given moment. A solid has tightly packed molecules. They are still in motion because with the kinetic theory we know that all particles are in motion, but they're so tightly packed that they just barely vibrate and you can't see them move. Once you heat a solid up and increase its temperature, you're giving the molecules more energy, so they then start to move a little bit more, giving more space in between the molecules, and it turns it into a liquid. And then as you increase the temperature of a liquid, you're increasing the energy and giving the particles more energy, so they start moving even faster, and they break apart from the things that are holding them together to then create a gas. Now, let's look at the physical properties of matter. These are characteristics that can be observed or measured without actually having to change the substance. Some examples of these: color. I can paint my walls, but it's still a wall. I don't change the substance when I do that. If I tie-dye a shirt, okay, I haven't changed the substance, it's still a shirt, but I've just changed the color of it. Now, state of matter, going from a solid to a liquid, or being a solid, liquid, or a gas, is a physical property. That's a physical property of matter. Its melting point and boiling point are all physical properties, and density is a physical property. Now, types of physical properties. There are two types. We have extensive properties and intensive properties. Extensive properties are dependent upon the amount of substance you have. So, example, mass, length, volume. If I have 5 grams of a substance and then I take some of it away, then I have only 3 grams after that. So that means the amount of substance determines what the mass is, and that's what extensive means. Intensive properties are independent of the amount of substance. It doesn't matter how much substance you have, it's always going to be the same. So an example of that is density, because it doesn't matter if I have 5 grams of a substance or 10 grams of a substance, the substance's density remains the same. Now let's look at chemical properties of matter. This is the ability of a substance to combine with or change into one or more other substances, and this is called a chemical property. Now, reactivity is one type of chemical property, and this is when two or more substances react with one another and join to form a compound. Flammability is the other chemical property of matter, and that's when something burns, and because it burns, it changes into a new substance. When you burn a match, you don't have the match anymore. You then have smoke, ashes, and then the remainder of the match. And so you turn things into different substances. It can have physical changes, and the physical changes are going to relate to the physical properties of matter. So this is when you alter a substance, but you do not change its composition. It's still the same substance. An example would be phase change, going from solid to a liquid. You still, like if I have a solid piece of ice and then I let it melt to a liquid, I still have water, so I've not changed the substance at all. Size, color, etc. If I take a pencil and I break the pencil in half, I've not changed what that pencil is, I've just changed the size of the pencil. Now, chemical changes, they're going to relate to the chemical properties of matter, because this is when one or more substances change into new substances. And there are evidences if you've seen a chemical change or reaction. One is color. Now, let's talk about this because we also said color with physical change. Color with physical change is when I paint a wall, when I paint a desk, when I color a piece of paper red when it used to be white. When you mix two liquids together and you have a color change, that's going to be a chemical reaction. If you mix a liquid with a solid and all of a sudden it changes colors, that's going to be a chemical reaction. So that's the difference between those. But if it produces a gas, if it produces a solid, if it produces heat or light, then those are evidences that you've seen a chemical reaction. Now, let's talk about this. When things go through changes, physical changes and chemical changes, you still have to obey the law of conservation of mass. Now, this law says that mass is neither created nor destroyed during a chemical reaction. So, it's kind of like when I talked with you earlier about the match burning. When the match burns and you only have a little bit of the match left, you still have not lost mass, just some of the match's mass has turned into gas, into ashes, and things of that nature. So the mass of your reactants, what you start with, always have to equal the mass of your products. So if I have magnesium oxide and I break it apart to change it to where it's then just magnesium and oxide by itself, I still have to have, I'm going to have the same mass of magnesium on the reactant side as I do on the product side. And the same with oxygen. So this is why we have to balance equations. This is the law that makes us balance equations. So don't be mad at me when you have to balance equations. Be mad at the law of conservation of mass. Because we have to make sure we have the same amount of atoms on each side so that we know that we've got the same mass on each side of the equation. All right, it's time to do our summary for today. And so this is how I want us to summarize for tonight. I want you to do a Facebook status summary. So pretend like you're putting a Facebook status up about your video tonight, about the most important points you saw. And when you make that Facebook status, make sure you write it down on your paper so that I can see it and bring your notes and your summary to class. And I'll see you when you get here.